Okay, hi. So hello everyone. I'm here with Brendan, right?
Yep. Nice to meet you. Thanks for having me on.
My pleasure. So I did a video about kubectl auto completion.
Yep.
Actually, I did a video about JS, which is a tool for looking at JSON files. And then
Yep.
the number one comment I got from people was, "What's that auto completion thing?"
Yep.
So I did a video about Fig. And afterwards, I was speaking to Brendan a little bit online and speaking about different issues with the kubectl auto completion and ideas for how to improve it. So we thought it'd be fun to do a video and just walk through a little bit about Fig and then see hands-on how we can play around with the Fig auto completion spec for kubectl. So
cool. Yep.
I mean, what is Fig, and or tell other people what is Fig and give it in a nutshell.
Sure. So the idea behind Fig is pretty simple. The terminal is really hard, and it turns out pretty much every developer uses it. And what we're doing at Fig is we make it easier for beginners, we make it more efficient for advanced engineers, and we make it more collaborative for teams. The way we're doing that is we're taking essentially what has been done in the IDE, that it's incredibly extensible. I'll look at VS Code as an example. VS Code has the extension store, it has IntelliSense, it has a language server protocol. There's so many ways you can enhance it. Whereas the terminal, most terminals at least, they don't have this extensibility. So what we've done is we've built this API layer on top of not just our own terminal, we actually integrate with every terminal, like the VS Code terminal, iTerm, the native macOS terminal. We have this API, and then with that, we enable anyone to build apps. We're essentially building like an app store ecosystem on top of the terminal. And the first app we've built, as you demoed, is Autocomplete.
Cool. Okay, so I'll tell you right now it's Mac only, right?
Yeah.
But I'll tell you
we're working on Linux and Windows. Don't worry, it's a big priority for us.
Yeah. No, I think it's a trade-off, right? Like there's two ways you can approach building something like this. Either you do what people have tried to do before and you like come up with fish shell or like with some or oil or whatever, and someone will turn it down. Or you say, I'm going to kind of do it from outside of the terminal itself. And then you have to at least start with a native approach for one operating system, but you can really do more interesting stuff and you can get it everywhere. Right? Is that correct?
I would say we're actually doing a third thing, which is pretty close to the second one. So you can do it at the shell level, like there's fish and oil and bash. You can do it at the terminal emulator level, which is you essentially build an entire new terminal emulator. So a modern terminal emulator might be Hyper, which is built by the VS Code, the Vercel founder. That's like an entire new tool. Whereas what we're doing is we're saying, don't change shell, don't change terminal emulator. Fig is actually an integration on top, like we're at the operating system level doing that integration, which enables you to keep using the tools you already use. And importantly, it lets you keep using, like if you use the terminal inside VS Code, we integrate there, which the shell integrates with, but a standalone terminal emulator does not integrate with.
So is it correct if basically I say you're like seeing, okay, there's like basically a text thing here on the page.
Yep.
And then when you click on that text bar, I'm like, you're essentially doing autocomplete on the text thing, but you have some context and knowledge about where it's located.
Yep. That's why it's really freaking hard. Is we need to know, like, here's an application we don't own. So you've got Chrome open right now. How do we know that Chrome is open, not iTerm, not something else? Like, how do we know it's specifically Chrome? How do we know where your cursor is, like your typing cursor? How do we know it's in it? If you're in VS Code, how do we know it's in the terminal, not the IDE part, not in the search box? And then finally is, how do we know exactly what you've typed in the terminal? And we have gone through a bazillion iterations on all three of those problems to try and get it working. And we've found some like pretty cool solutions. Now it's super robust and performant.
So are you doing like a different solution for each one of those individual things, or like is it custom tailored for each option?
For each terminal emulator, the way we get what you've typed, we use a thing called a pseudoterminal, which is essentially you have the history of the terminal is fascinating as to how it's, this physical machine that was the terminal in the 70s has ended up being this thing that's on your computer that you still use, but it's like the constraints still exist the same. So there's basically a terminal is the screen and the keyboard, and the shell it's the brains. It's the mainframe that used to take up an entire classroom. And what we do is we add a thing called a pseudo terminal in between those. So when you're typing, like, it is sending something through Fig pseudo terminal, and we're just like essentially sending those events to our desktop app. So it's all local, but like that's how we're intercepting what you've typed. We used to do it at like the operating system level. It was effectively like a keylogger. You type up some letters and then we would try and predict what you had typed. But as soon as you hit something like Control-C or a key binding, we would have no idea what you typed. It just didn't actually work well. I'll go quickly, but then to get your cursor position, some of the terminal emulators expose it, others don't. We can do that at the operating system level. And then to know which Windows is open, that's also an operating system integration.
But you're essentially sniffing like the PTY, right? You're like sniffing the traffic on the PTY, and then now
it's like sniffing makes it sound bad and scary. Like pseudoterminals is the way SSH works, is the way Screen works, is the way like most of these bigger CLIs work, and we're effectively the same.
Yeah, no, I don't mean sniffing in a bad way. Like I
yeah.
We're like a background, so like that's my way.
We're a pass through. We're like it's a pass through layer. Yeah.
Cool. There's like this article online that whoever has Googled PTY comes across, right? And it like goes through the whole. Do you know what it's called? You know what I'm talking about?
I've probably read all of them at this point, because when we're trying to hire people and they're like, "What the hell is a pseudo terminal?" We end up sending the same article. So yeah, I'm sure.
So there's this like article about PTY, like everything you want about PTY, and goes through the whole history. And I probably come around that like once a year on my birthday, and I read it and I understand nothing, and I think, okay, I'll come back to that next year, and maybe I'll get smarter and I'll understand it this time. But that's cool though. That's cool. It's like one of those areas of operating systems I've never really properly understood.
Well, it's sort of crazy it still exists, quite honestly. Like we are emulating a physical machine from the 70s on our MacBook Pro. Like it doesn't quite make sense, but it sort of does, in that everything has to be backwards compatible, and that's why we still have these constraints. Like if you change the way the shell output stuff, things would just break, like everything. Server, like just so much is dependent on this exact standard staying the same that it has to stay the same.
Okay, cool. So let's jump right into it. I guess that's enough theory. Let me go over here. So essentially the reason why I think we originally started talking, let me see if I can, so that's out of the way. Okay, so if I type here, let's say kubectl get.
Yeah, I'm not sure what's going on. Are you sharing your, oh yeah, Fig was showing up before. Try hitting Control-C and just going to a new line. And also make sure Fig is open.
Yeah, I might mess something up. Let me open up the new shell.
Cool.
This might be something specific with my machine, because I've seen this happen before. So
I would just try Fig restart, and
wait, I think this is now. Okay, Fig restart.
Yeah. This also is a problem that happens with Zoom screen sharing, surprisingly, because we're trying to work out which window is open, and the way Zoom does screen sharing is a little finicky. So it's like usually a Zoom issue.
Cool. No, that's fine. That's fine. Like I said earlier before we started recording, like I'm an early stage founder myself, and like we did a live demo with David Flanagan on Raw Code, and we were like about to show people these features, and turns out that one of our developers pushed something that morning which broke it. So I understand, and that's the problem with live demos, but I mean that's fine. Okay, so now if I hit, I think what we wanted to do actually here was like kubectl logs. Now if I hit tab here, then
what's you doing, logs or log?
Oh, maybe logs.
Yeah, there you go.
I think log is fine too. There's like a thing they do with the kubectl commands where I think you can tack on s or not tack on s. Maybe that's actually a good thing to try and go and fix in the spec.
Yeah, that's great. We could do this live if you'd be interested, but yeah.
Yeah, I'd love to. Let me just check that log actually works. I'm gonna run kubectl pods. What's your Kubernetes like?
We like zero. Don't use kubectl at all. Reason why is that a lot of our stuff is hosted by like open source cloud providers like Cloudflare or CDN.js or something. So we don't have crazy high server costs. We just have no reason to do kubectl or Docker or anything right now. So like pretty simple setup, Vercel for our front end. It's like, yeah, not too bad. The hard stuff is the Rust backend that we're doing. That's
okay. Yeah. That's what's running in the, that's what's running locally on my machine though, right? Or is that what's running on your server?
Yeah, Fig is, we add some integrations to your shell that can set up this pseudo terminal. We have a desktop app, which is receiving all of these events. And then we actually just have a web view. It's like natively built web view. We're not using Electron. And that's the sort of front end app that we're building. So like that is actually the easy part. And then the hard bit is, also I'm sorry about this noise, but the hard bit is getting all the events and sending the right events to the web view.
Okay, yeah. Okay, so it turns out that I was wrong and kubectl log is not a command. So
Cool.
I do
Love it.
logs. So that's my mistake. But let's do, right. So what I think what we were originally going to do is like, if I do this now, mess something up. Okay, yeah. Okay, so if I do kubectl logs and I try and autocomplete, I think this is the same issue we had before. 1 second. Yeah, okay.
So you have tab 2 autocomplete on, which is a setting where Fig doesn't show up automatically. Fig only shows up when you hit tab.
Yeah. That's correct. I changed that.
Yeah.
So, okay, let's say I do kubectl logs, and then I'll say like, I hit tab. So by default, I think this is auto completing it to, so I can do something like deployments, like slash, and then the name of the deployment. So in Kubernetes, you have deployments and you have pods, and pods are part of deployments. And there are two forms of the kubectl logs command. One where you write something like deployment slash robusta or whatever. And the other where you write like kubectl logs, and then you could say pod slash something, but instead I'm just going to do like, you can give it the name of the pod. So like robusta runner.
Sure.
And I think right now the auto completion here only supports that first mode, right? Where I do write logs. So what would it look like if I wanted to go and now fix that auto completion spec?
So this is wouldn't be something we'd be able to do on the call, unfortunately. The way Fig treats CLI tools is we essentially take what you've typed, we more or less split it on spaces. It's not exact, like we have a bash parser that's doing all this, but we then map each token to our completion spec. A completion spec is just a tree that says the subcommands, the options, and the arguments that comprise any CLI tool. So rather than kubectl, let's look at Git. Git is the top of the tree. Underneath that, we have a bunch of subcommands. We've got command.
Brendan, can I show this on screen? Like, can I open up?
Yeah. So go to the docs, fig.io/. Oh yeah, sure. Let's do source. This is great.
So let me take. Git.
Let's look at what's one with subcommands? Maybe ls is maybe we could build one live. I could build it live if you'd like me to, or we could go to kubectl. Let's do kubectl.
Okay. Yeah, I actually have that open, I think. Okay, yeah. So this is, so I was looking at this a little bit before the call. How do I understand, like, okay, I want to jump into this.
Yep.
And so I want to find the place that's like running kubectl logs, right?
Yeah. So you should look for logs. Just do Command F, logs in, there are a bunch of results. There you go. So as I said, you have the CLI, the name of the CLI at the very top, and then underneath that, you have a bunch of subcommands. So you've got like logs and whatever else. Like, as I said, I'm not the kubectl guy, so I'll just use Git. You have Git checkout, you have commit, you have stash, you have whatever else. It's just a tree, and you're just walking down the tree, and then every subcommand can have an option. So I do git commit -m, right? That's a -m is associated with the commit subcommand. It's nested underneath. And then both subcommands and options can take arguments. So I git checkout a branch. The argument to checkout is a branch. The argument to -m in git commit -m is a message. So in the logs case, we like it takes, you said either a pod, or you can have the pod name / the name of the pod. Was that correct?
Yeah. So it would either be something like, if I jump back over here, it would either be kubectl logs and then like pod name, or it would be deployment or some other type and then
/ pod name. Yeah. So the way Fig generates suggestions in two ways. One is there's the predefined suggestion. So subcommands, options, those are preset. Like in very, very few CLI tools are you like generating subcommands at runtime. Whereas arguments, those are not preset. Like git commit -m, you can have any message in the world. So like, how do we generate suggestions for that message? Sometimes those are predefined. So in the Git checkout cases, you can check out a branch, you can check out a commit hash, you can check out a tag. And so we just generate suggestions for those arguments. And so we have a concept of a generator, which is we're literally running a shell command, getting the output, passing it, and then turning it into a list of suggestions. So for Git checkout, we run git branch at the current working directory the user is in. We get the output and we pass it. We run git tag or tags or something like that to get the list of tags. We're doing all of these. So we're generating suggestions here. And so the hard thing is, if you think about kubectl with how many arguments you could pass into logs, is you have, if you scroll down, see how it says args, and then it has 2.
I just want to understand what I'm looking at here. So this is a spec for kubectl logs. So args here is like the proper named parameters, right? Like not named parameters. I mean, that's the stuff that's going to come without a dash dash. And then below I have the options, which are everything, like all the options I would pass with dash whatever, right?
Yes. So here you've got logs. There's a description for it. Logs takes 2 arguments. So I can type git logs argument A space argument B. And then options, there are a bunch of other options that I can do. There's the dash F, the dash C, the dash dash all containers. I can do all of those. That's essentially logged.
What does this mean though? This I get. I'm essentially saying the first argument is going to be something like kubectl logs, and then like type or whatever, or type slash something.
So this is our schema. Really, a completion spec is a schema for generating suggestions for a CLI tool. And so this schema says, hey, logs takes 2 arguments. The first argument is we've already like this is just TypeScript saying we've defined this argument probably because it's used somewhere else. And we're calling it's the shared args.type or type/name argument. So this is what you're saying is you can have the type or the type/name. So can you right click and then go to source? Maybe not, you may have to command F it.
And search it,
21.
I think I saw that. Yeah, okay, so.
Okay, so here we go. Now this is what it's saying. So the name of this is type or type/name, which is just like this is descriptive text that is going to show up for the user. And then here we have the generator. And so this generator is, it's a special type of generator because this is a more complicated thing, but it is, so we actually should be generating suggestions for the slash. That should work, but you can see that we're running a type.
I think essentially what I want to do here, this more accurately in the case of kubectl logs, it wouldn't be type or type/name. I think it would be name or type/name. Let's say now wanting to take this back though, and then like copy this function, edit it around. Is that something I could like do right now?
Yeah, if you hit dot and open it up in GitHub.
No, but could I now take a version of this back and then run that by me locally?
Yeah, you would have to clone the repo or fork the repo and clone it. So go to fig.io/docs. Don't do this exact thing. Here, go back to autocomplete.
No, but can I take this raw and just like download this one file, or do I have to download?
You'll need our runtime to compile it. So like we have all of this developer tooling to make it really easy. So click on fork and then top right.
Yeah.
You want to just fork it, clone it. And then I'll show you, you can get this set up and you can test it locally, like very, very easily. Just you may have to turn off the autocomplete on tab setting. You may not, I think it'll be fine. I've never really tested it, honestly. But okay, so clone this down to your local device. You can test this live. You can make these changes live.
Okay, so I'll take this and that of course is Fig in action.
Love it.
Okay, so git clone.
So we've built a ton of tooling around this to make it like the testing experience really good and really simple.
Okay, cool. And now I assume I go into autocomplete.
Cool. Yeah, I don't know what editor you use, but if you use Vim, just open it up, do code dot or something. Yeah, okay, Vim. You might do npm install.
Yeah, npm install.
Yeah. And now you can open this up in Vim. What we're going to do is go to source and then actually let's create a dummy spec first, just so you can see how it works. And then I'll show you how it works with, so when this is done, do npm run create -spec. And we're going to create a spec and we'll call it ABC or something stupid like that.
Okay. Yeah. But when I'm taking this folder, right, like I'm essentially overriding all of the auto completion specs at once, right?
So the way Fig works is that repo with Fig/autocomplete is the source of truth for all the completion specs. So when I'm a user, the cool thing is if someone pushes something new to this public repo, let's say they push the dog spec, I type dog space, and suddenly it'll start showing up because this thing is the source of truth. What you're doing here is you're downloading that locally, and you're going to turn on a setting when you sort of like set up the dev environment, which tells Fig to only look for completions in a specific folder. Don't look at the with Fig/autocomplete repo. You can turn that on and off as much as you like. And so this is how you edit and make changes. And then what you're going to do is you'll make a change, push it to the cloud, it'll get merged in. Suddenly every user in the world is going to have access to this. So do npm run create dash spec.
Create that spec.
Dash hyphen.
Spec, yeah.
And we're going to call this spec ABC.
I'll tell you what, let's do something different. Instead of fixing kubectl, let's do one for Robusta. That's why.
Sure, cool. That's awesome. Yeah, let's do it.
Whoops.
You may have to Control C. I've seen this bug a little. Just Control C out of there.
Okay. Yeah. So.
Yep. Cool. Okay. So you see the same structure as before. Change the name of this subcommand. Oh, we don't even have to change it. This is like an example spec that we've created. And you can see it should have a name called my subcommand. It should have a subcommand underneath that called my nested subcommand. Like you can see this general idea. What I want you to do is go back and run npm run dev. And now open a new tab.
Yep.
So we've just compiled all the specs and now type Robusta space and hit tab. Okay. This is why I haven't seen it work with the only show on tab. So if you want to try Fig settings and just turning that off.
Yeah, I can turn that off. Hang on. This, right?
Yeah.
And then I hit like Robusta. Oh yeah.
Yeah.
Okay.
There you go.
I wonder if that's also related to the bug I was hitting earlier. Okay, so I'll
probably, yeah, the only show on tab is a little finicky because it's about like interceptions at the top level. And yeah, we definitely optimize the experience for always on experience. So yeah, type Robusta space and you can see. So now hit enter on my subcommand and then hit space again.
I want to do something real though. Like I want to, let's see what I have here.
Sure, I'm just demoing the, yeah, sure. Okay, let's do that. You can copy all of those. Just copy that whole section.
Now, if I change it, if I change it, then will this npm here reload?
Yep.
So I just can go here, cd autocomplete, and now Veeam Robusta, right? Now what did we call it?
You want to go source.
Oh, sorry.
SRC, yeah.
And Robusta.
Yep. Okay, so subcommands, you want to change this to, all you want is a, demo, cool.
And we'll call that make stuff crash. Our demo make stuff crash, like to the everything.
Yeah, cool.
And then
you can delete the nested subcommand. Yeah, great.
Okay.
Cool. Yep, save that.
Now that will like reload.
Yep, it's already compiled, already done. So just type Robusta space. There you go.
Nice. And then I can see here like make stuff crash.
If you hit the down arrow, yeah.
Okay, and then this deploys a crashing pod and like Robusta will do stuff, but okay. So that's cool.
And so
take it as homework to try and see if I can fix something with the kubectl one.
Yep. So I would go through fig.io/docs and that tells you all of this. It just runs through exactly what I just went through with you. You're probably gonna have to turn off the only autocomplete on tab setting just because we don't as a team use it. And so that's probably why we haven't optimized it. So little things like testing, we like now I know we'll go back and we'll fix this. But
no worries.
It sort of walks you through how you think about a Fig spec and then how to write these generators to generate suggestions for things. And it uses Git as the example because everyone knows Git and you go, oh, well, that's how Git checkout works. This is how Robusta demo is going to work. Yeah.
Well, I have a question. I have another question about this. Like if I'm looking at, I'm looking here, let's say at Robusta. Let me just open up the code for our CLI. We're using Python and we're using here typer. So, where is it? Okay, we're using the typer library. And then like when you define commands here, it's like using where is it? You use like some app command, and you put in decorator before each of the functions. And then if I go back here, like let's clear that. If I just do robusta, let's say, and I'll do help, then I can like generate bash completion automatically. So is there a way I can take bash completions like this and then like automatically convert that to some fig?
Yep, that's so for Typer, not currently. For a lot of other frameworks, yes. If you go to fig.io/teams, if you want to do this now, you can see all of the frameworks that we actually have. So we integrate with Cobra for Go. We integrate with like Commander and Oakcliff and maybe Yargs for JavaScript. So fig.io/teams. And this takes you to the docs. And it's because Teams builds. So you can see on like Cobra, Oakcliff, Commander, Clap, Swift argument parser. We don't have one for Click with Python. We don't have one for the Python main arguments or for Typer. But like now I know it's a priority. We can build this. And the idea there is you shouldn't have to change your CLI and then go and change the fig completion spec. That should just happen automatically. So yeah, with these integrations with Cobra and Oakcliff, we do all the hard work of spitting out the completion spec, and then it just auto merges to like public repo.
That's really cool. Okay. So this has been really cool. Anything else you want to add before we wrap up?
No, we should get the robust completion spec working. That's so Typer.
I'll want that for my own usage. So I'll see about it.
Cool. Love it.
Afterwards. Okay, so let me just stop the recording.